Hi, John Valvano here, and in this video we're going to look at topology. Okay, now basically topology is how various nodes of our communication network are connected. Okay, so the first one we're going to look at is called peer-to-peer. Sometimes it's called point-to-point. Okay, and then peer-to-peer, we have basically two objects, A and B, and they can communicate with each other. Okay, so B can send to A can send to B. We saw this in 319K, where we had one microcontroller here, one TM4C here, and we had a UART. And with the UART, we connected to a second TM4C and used the UART in the other one to communicate between the two. That was point-to-point. Another example of where you would see point-to-point is in Bluetooth. So if you had a Bluetooth low-energy device, you could connect up to your phone or another device, your computer. Okay, so with Bluetooth low energy, it's basically a paired. It's a paired communication. Okay, some of the advantages of peer-to-peer is it's simple. That's nice. Because it's simple, it's going to be low cost. Okay. Some of the disadvantages are that that it's hard to extend. It's in fact you can't put more. You only got two. Hard to extend. Okay. There's no real. There may not be much security involved. Security is not built in to many of these protocols, and so. It's simple, yet it's limited. Okay. The next one I want to talk about is star. Okay, and with the star network, what we have is a single master. Okay, which then can communicate with multiple slaves. Okay, multiple slaves. And in this context, let's say we had a sensor network where these might be sensors. These are sensor nodes that are collecting data, and they're connected up to a master recorder. So this is going to record or save the data. Now it may be connected to the internet. Okay. This is a classic way to do it, and a lot of protocols will handle this master-slave. You could do it with sub-gigahertz. You could do it with Thread. You could do it with Wi-Fi. Okay, you could do it with Wi-Fi. So with a Wi-Fi-enabled device, we could have a single ESP8266. Basically satisfying the server that we talked about last time, and then have multiple ESP8266 slaves, which would then be clients. Okay, so we'd have multiple clients, and then use Wi-Fi. Use Wi-Fi to communicate between the two. Because the 8266, most Wi-Fi enabled devices can serve either as a client or as a server. Okay. Now, the advantage of this is obviously it is flexible in terms of the advantages of this is it is easy to extend. Okay. To add more nodes. Okay. It does give you a strong sense of control. When a master slave, you know what you're doing because you have a master controlling it. Okay, and so the disadvantage okay, if there's going to be a disadvantage of a master-slave, is the master has to reach all the slaves. Okay, so it's a very small, it's going to be for a localized only. Okay. Whereas in the next protocol, okay, where we have a mesh network, now there's no particular master slave, okay, but we have multiple nodes, and the node basically can communicate with any node that's within a range. So if a node is within range, it will communicate. You could do this with sub-gigahertz. You could do this again with thread. You could do this with LoRa, long range. You could even do this. No, you're not going to do it with Wi-Fi. So we're going to do a mesh network, and the advantage here is also easy to extend, and it's very dynamic. So a typical mesh network, you don't decide ahead of time what all the connections are. You discover them. So it has a fairly long distance, okay? As long as the first one, as long as you can communicate with another one, this node here, A, and that node there, F, may not be within communication range, but as long as they both exist in the same network, that's an advantage. Okay, so that's a mesh network. Again, we also use it as an application. We can use this for sensor nodes as well. Sensor network. And if you remember the definition of an IoT device, it's an embedded system that eventually connects up to the internet. So a very typical use case in a sensor node network is to have your nodes all in the field, moving around. It's also mobile here. This has the advantage of mobility, moving around. But you have one of them, you designate one of them here, okay, as the interface to the internet. So if you can place this one here, the bridge to the internet. So in this context, all the other nodes don't have to have internet capability. As long as one of them does, this sensor network can then stream data onto the internet. Okay. So it's a very dynamic mesh network. Good examples of this are Zigbee. Zigbee is a classic example of a mesh network. Okay. A local network. Well, each of these is a little bit different than what we're going to do in lab. So let's draw the topology of the lab network. Okay, so in lab 4, we're going to have your TM4C connected to an ESP8266. And this is your clock. And that is going to connect ourselves up to a Wi-Fi hotspot. Okay. I use the one on my phone, but there's a couple in the building, okay, that you can use if you want. Just ask us for the password and the ID. Okay, so we're gonna open up sockets. We're gonna send TCP packets. We're gonna do domain name service requests, etc., through the ESP8266 to the hotspot. Now this hotspot is then in turn going to be connected to the internet. Okay, which is a big amorphous network to allow you to send things across the planet. Okay, somewhere else. There's another hotspot, okay, Now, it may actually be the same one, but nevertheless, we're going to assume they're different. They don't have to be the same. And we're going to have our phone here. And communicate our phone. Okay, so again, we're going to run a blink application here. Going to run a blink application there. But as we communicate between the alarm clock and the cell phone, it's going to go through the server, the blink server here. Okay. So this is neither point-to-point nor mesh nor star. It's an internet topology. Okay, so in summary, we saw three kinds of topologies. We saw peer-to-peer. We saw star. We saw mesh. And we saw the internet. Okay, and each one has its advantages and disadvantages. Okay, enjoy lab.